Welcome to science class. Today we will be discussing the features of Jupiter, Saturn, Uranus, and Neptune. Jupiter and Saturn were known to all ancient cultures. Uranus and Neptune were discovered. It is actually possible sometimes to see Uranus unaided, and we think we have documented examples from astronomers in the past who recorded Uranus's position in the sky, not knowing it wasn't a star. Jupiter was the Greek Zeus. Saturn is his father, who was Kronos to the Greeks. Uranus is actually the Greek god, the only planet without a Roman name. Uranus is the god of the sky, and Kronos' father, Zeus's grandfather. Neptune is the Roman version of Poseidon, the god of the sea. Each of these planets is much more similar to each other than the terrestrial planets are to one another. But still, each one has just a few extremely unique characteristics. Let's get started. Located 778 million kilometers from the Sun, 5.2 astronomical units, Jupiter is 2.5 times more massive than all of the other planets combined. It's huge. So massive that even though it is more than 10 times the distance from Earth than Mars is at their closest, Jupiter is still distinct through an ordinary telescope, and their brightness in the sky is virtually identical. Jupiter is over 1,400 times the volume of Earth, but only 318 times the mass of Earth. That is because it is composed almost entirely of hydrogen and helium, mostly hydrogen. All of the Jovian planets are that way. This also makes the surface gravity nowhere near as strong as you'd think on Jupiter. You'd weigh 2.4 times what you do on Jupiter than on Earth. Remember, gravity pulls you towards the center of the planet, not its surface. Jupiter is so huge and its matter so spread out that much of the extra pull is negated by the planet's gigantic radius. All that being said, you couldn't actually stand on Jupiter. It's a gas planet after all. The interior of Jupiter is probably made of a ball of rock and metal. Who knows how big? We just aren't sure. No technology can peer through Jupiter's immense hydrogen-helium structure, and we can't just descend down to the core with probes. The atmospheric pressure of the planet would crush any man-made object into oblivion. That being said, we have fired probes into Jupiter and collected some data. Jupiter is capable of producing so much pressure that the hydrogen within it exhibits bizarre properties. Deep within Jupiter, the pressure becomes so great, over 5 million times the pressure of our atmosphere, that the hydrogen molecules are squeezed into liquid. When you increase the pressure on a gas, you drive the temperature up. So this compressed hydrogen liquid is even more impressive because it's a hot gas squeezed into a liquid state. This liquid hydrogen also conducts electricity. Don't ask me how, but this giant volume of rotating liquid metallic hydrogen generates a magnetic field. The magnetic field of Jupiter is around 20 times the strength of Earth's, but its size is amazing. If we could see it, it would look as large as the full moon, which is more than 1,500 times closer to Earth than Jupiter. Jupiter's magnetic field isn't as uniform as Earth's because of the nature of how it is generated. But still, Jupiter experiences auroras like Earth does, only much more impressive. While flying to one of the moons of Jupiter or taking an orbit around it would be a magnificent sight and experience, getting close to Jupiter would kill you. Magnetic field lines that wrap from pole to pole trap energetic charged particles from the solar wind. On Earth, these are called Van Allen belts. The amount of radiating particles trapped near Jupiter is so great that you'd likely be killed in minutes. Jupiter has 79 known moons, the vast majority of which are captured asteroids. While some of them are many kilometers across, about half are less than 4 kilometers across. Jupiter's 4 largest moons, the Galilean moons, account for 99.7% of the total mass of all Jupiter's moons. When you think of Jupiter, you think of one main thing, the Great Red Spot. This great red spot is a hurricane 3 times the diameter of Earth. It sits right at the border of the southern equatorial belt and the southern temperate belt. Jupiter's fantastic colors come from ammonia, acetylene, and cyanide-like molecules mixed among its atmosphere. Jupiter's outer atmosphere rotates in different directions in distinct bands. Using time-lapse footage, you can clearly see how some belts rotate east to west, while others rotate west to east. While the Great Red Spot is a huge storm that has persisted for, well, we don't actually know, but at least 400 years. Many hurricanes of gigantic proportion constantly pop in and out of existence on Jupiter, and they mainly occur along the edge where one belt goes against the current of the other. On Earth, the wind comes from the unequal heating of Earth's surface and by extension its atmosphere. This creates low pressure and high pressure areas, and the air migrates towards low pressure areas. Jupiter is much too far away from the Sun for its surface to be impacted by solar radiation. So how do such epic winds occur? The source is the difference in heat between the planet itself and outer space. Jupiter is highly compressed gas, and while the temperatures in the outer atmosphere are around negative 150 degrees Celsius, deep within the planet, the temperatures are many thousands of degrees Celsius. One of the weirdest discoveries, and a recent one, about Jupiter is that it has clusters of cyclones at each of its poles. There are 9 of these cyclones at the North Pole and 6 of them at the South Pole. Each cyclone at each pole rotates in the same direction, clockwise in the south, counterclockwise in the north. Why these storms exist in the first place and why they keep spinning despite the interference from all spinning the same direction is not yet well understood. Jupiter is the fastest rotating planet. Its day is around 9 hours and 56 Earth minutes. A year on Jupiter is 12 Earth years, 4,332 days to be exact. Because Jupiter's sidereal day is much shorter than ours, there are 10,476 Jovian days in a Jovian year. Jupiter is tilted at just 3.1 degrees. The first spacecraft to encounter Jupiter was Pioneer 10, which reached the planet in December of 1973. Voyager 1, which launched in September of 1977 and reached Jupiter in March of 1979, discovered volcanic activity on one of Jupiter's moons, Io. The first craft to orbit Jupiter was appropriately named Galileo, which reached Jupiter in December of 95. The Galileo spacecraft dropped a probe into Jupiter's atmosphere to study it, the first one to ever do that. When the craft had nearly run out of energy to keep operating, NASA decided to kamikaze it into the planet. Juno reached Jupiter in August of 2016 and has collected a huge wealth of new data and pictures, including most of the ones I've shared in this video. Juno is the Roman Hera, Jupiter's wife. One last point about Jupiter. You may owe your life to it. Jupiter's gravity is so immense that it fundamentally shapes the structure of the asteroid belt. The asteroid belt is kept in a sort of rotating triangle, thanks to Jupiter. Statistically, dinosaur-killing level asteroid impacts and other minor impacts, like this one seen in Arizona, which would cause massive wide-scale climate change and death, should occur more often than they do on Earth, based on the amount of material that just happens to be in the solar system. Jupiter's gravity prevents many of those things from flying in our direction. Thanks, Jupiter. Located 1.4 billion kilometers from the Sun, 10 astronomical units, Saturn is 83% the diameter of Jupiter and over 9 times that of Earth. But Saturn is well over 3 times less massive than Jupiter. Saturn is the least dense planet, less than 1 gram per centimeter cubed. It is an amazing sight to behold through a telescope. The first time I ever did this, even though it was kind of just a speck, it gave me an overwhelming emotional experience. While Saturn is over 95 times the mass of Earth, your weight would not be significantly greater on Saturn. Again, because the planet is so large, that you are extremely far away from its center. Again, like Jupiter, you couldn't actually stand on Saturn. It's a gas planet. Saturn, as well, likely has a rocky metallic core, but likely a much smaller one than Jupiter's. Saturn is not a uniform color when you look at it closely, but its beautiful pale yellow is caused by trace amounts of ammonia, phosphine, water vapor, and hydrocarbons in its upper atmosphere. The vast majority of the planet is, of course, hydrogen and helium. Saturn has a very strong magnetic field. Like Jupiter, Saturn's interior also generates liquid metallic hydrogen. Auroras happen on Saturn too. Saturn has 62 known moons, only 13 of which have diameters more than 50 kilometers. Titan, the largest moon of Saturn and overall second largest, accounts for well over 90% of all the mass of Saturn's moons. When you think of Saturn, you think of one thing: rings. Saturn has 7 ring groups. These rings are just density bands of orbiting material. They appear almost like solid structures, but they aren't. They're composed of countless fragments of icy material. The ring structure is 250,000 kilometers across. That's 2/3 the distance to our moon. Despite the incredible width, the ring structure is only on average 10 meters thick. Yes, seriously. To give you an idea of how crazy that ratio is, it's the same as a sheet of ordinary printer paper, but 1.25 kilometers across. Because of the narrowness of the ring structure, it's not nearly as massive as you'd think. If the whole ring structure were compressed into a single body, it would only be about 100 kilometers across. And we have no idea where Saturn's ring structure came from. Maybe its gravity ripped an icy moon to pieces. Maybe a comet directly hit a tiny moon and they obliterated each other. We just don't know. Saturn has a few other interesting characteristics. One is a giant hexagonal jet stream over its north pole. Saturn is the second fastest rotating planet. Its day is only 10 hours and 42 minutes. A year on Saturn is 29 Earth years, 10,759 days to be exact. Because Saturn's sidereal day is much shorter than ours, there are 24,491 Saturnian solar days in a Saturn year. Saturn is tilted at 26.7 degrees, so its orientation of its rings observed from Earth changes over time. The first craft to visit Saturn was Pioneer 11, which reached the planet in 1979. In July of 2004, Cassini reached Saturn and continued to collect data until September 15, 2017, when NASA deliberately decommissioned the craft by flying it straight into the planet. Cassini also carried a probe that was specifically designed to land on Titan, meaning Titan is the only other moon we've ever landed something on, so far. Located almost exactly 2.9 billion kilometers from the Sun, over 19 astronomical units, Uranus is 14.5 times the mass of Earth. At almost 51,000 kilometers across, it's just under 4 times the diameter of Earth. And for the record, I'm saying Uranus because that's literally how you pronounce it. Uranus is a lie we all believe, like that the North Star is the brightest star in the night sky, which it isn't, or that the phrase goes, for all intensive purposes, when it's for all intents and purposes. Uranus is mostly hydrogen and helium, of course, but it has one of the prettiest colors of any planet, at least in my opinion. The awesome pale blue comes from methane and hydrogen sulfide. Apparently, the atmospheric pressure is so great within Uranus that these methane molecules break up and their carbon is compressed into diamonds, which then fall into the mantle of the planet as diamond hail. That's all speculative, but it's backed up by experimental findings, not just make-believe. The surface gravity of Uranus is less than that of Earth, 8.69 meters per second squared, and so you would weigh less on a planet with 14 times Earth's mass because you're so far from the center. Yes, once again, you can't literally stand on Uranus. It's a gas planet. Uranus's moons are all named after characters from William Shakespeare and Alexander Pope. When you think of Uranus, you think of one thing. It's sideways. It's actually more than sideways. Its tilt is almost 98 degrees. This makes its north pole beneath its south pole with respect to its plane of orbit. Uranus also has retrograde motion because of this. It spins clockwise when viewed from what we call above in our solar system. And we have no idea why it is tilted that way. A day on Uranus is 17 hours, 14 minutes. It takes Uranus 84 Earth years to orbit the Sun, 30,688 Earth days. But because its sidereal day is shorter than ours, there are 42,718 Uranian solar days in a Uranus year. Uranus also has a ring system. They're not as distinct as Saturn's. They're composed of extremely dark particles that don't reflect much light, unlike the icy ring fragments of Saturn. Now, I didn't give you very much information on Uranus because we've only ever flown one craft to Uranus or Neptune for that matter, and it was just a flyby. Voyager 2 launched August 20th, 1977, 15 days before Voyager 1 for some reason, reached Uranus on January 24th, 1986. Obviously, the technology of this satellite is almost Stone Age compared to what we are capable of today, but in any case, it is our only mission to Uranus, and it made most of the major discoveries I've shared with you. Something worth mentioning about Uranus, though, is that it was discovered. You can't see Uranus from Earth without a telescope. Several people documented Uranus, but because it is so far away, it's hard to tell that it's actually moving and not stationary. So these people all thought it was a star. William Herschel, who also discovered infrared radiation, was the first to identify Uranus as something other than a star, but he thought it was a comet for a long time. He identified it on March 13, 1781. Anders Johann Galle worked out the orbit of Uranus, determining it was nearly circular and therefore most likely a planet. Comets almost always have wildly elliptical orbits. William Herschel got to name the planet, and he called it Gregorium Sidus, which translates to George's star, for King George III, who was the king at the time of the American Revolution. Now, that is a horrible name. Herschel's justification was that it should be named after the time it was discovered, in the time of King George. Luckily, popular opinion won out, and eventually the official name Uranus was selected by different scientific groups. Located almost 4.5 billion kilometers from the Sun, almost 30 astronomical units, Neptune is 17 times the mass of Earth. At over 49,000 kilometers across, it is not as wide as Uranus, but it is denser because it has more mass. Neptune and Uranus have about the same composition, with Neptune likely having a larger, solid, icy, rocky, metallic core. The deep blue of Neptune is a bit of a mystery because it does not have any known trace gases that Uranus does not. The surface gravity of Neptune is 11.15 meters per second squared. Neptune has over a dozen known moons, the largest of which is Triton. The others are just medium or large-sized asteroids. Neptune also has 3 very thin rings. A day on Neptune is 16 hours, 6 Earth minutes. A Neptunian year is a soul-crushing 165 Earth years, or 60,182 days. But because Neptune spins faster than Earth, a Neptunian year is really 89,666 Neptunian days. Wicked. Neptune is tilted at 28 degrees. As mentioned, we have only ever visited Neptune once with Voyager 2. It reached its closest point to Neptune on August 25th, 1989, 12 years and 5 days after it was launched, even though it is traveling through space at almost 58,000 kilometers per hour. The solar system is big. But anyways, we don't know that much about Neptune because of this solo flyby. We did observe that Neptune had a great dark spot on its surface, but when the Hubble telescope looked at Neptune much later, that spot was gone. New ones had popped up in its place. Neptune's upper atmosphere has huge clouds of various different gases, and incredible wind speeds. Winds blown on Neptune at almost 2,000 kilometers per hour, faster than anywhere else in the solar system. Like Uranus, Neptune was discovered, but Neptune's existence was calculated before it was ever seen. If you'll remember from when we covered Kepler's laws, the ratio of an orbiting planet's year and distance from the Sun isn't always perfect. That's because of the gravitational influence of other planets. After Uranus had been observed for a few years, astronomers came to understand that its path around the Sun was not what it should be. Something that they couldn't see was interfering with it. A French mathematician named Urbain le Verrier used orbital mechanics to predict where this interfering body should be. He sent a letter to the Berlin Observatory, and astronomer Johann Galle spotted Neptune the night he got the letter, September 23, 1846. The position was within 1 degree of where it was predicted to be. John Couch Adams, an English mathematician, had been working on the problem at the same time, but Le Verrier beat him by 2 days. That does it for the planets. Next time, we are going to take a close look at some of the most intriguing moons of our solar system. Thanks for watching.